This is the AUI. We've been talking about it. This is what the screen looks like when you walk up to it, but this is static. I'd rather go live. So I'm going to try to switch this thing around and take a look at the transmitter that's on the air down in our lab. And hopefully this is all going to work. My darn, there we go. So now we're looking at the AUI in the lab, and we have an NV40 that's operating at 32 kilowatts in HD mode.
That's right. This system has been running in our engineering lab for a while, and we're conducting tests and experiments and trying to get the features of the AUI that much better and load in various other lovely features. When you first turn the transmitter on, this is the screen you're going to see. As you can see, there's a very intense level of instrumentation that's been provided. We have metering in case of troubleshooting. We have the exciter status. It tells you which exciter is active. The modulation meter is a very important function. Date and time, and of course, the biggest thing you're concerned with is how much power am I actually putting on the air.
Mm-hmm. Okay, can you walk me through the screen? Tell me what I'm looking at here.
Yes, so right here we'll see this little section is basically what we call the task area. So in this example, we see an audio spectrum analyzer. Yes, that is an audio spectrum analyzer. This is all built into the transmitter.
What's it looking at, Scott?
This right now is actually looking at the composite baseband.
Okay.
And you can see the left plus right and the pilot and the suppressed 38 with the left plus right in the stereo.
Double sideband suppressed stereo.
And you actually see an SCA carrier.
Let's see. Now, I noticed this thing has a marker on it that I can use, so I'm going to take and move that marker across and see what my levels are. It's just like an instrumentation spectrum analyzer. So there's my 19 kilohertz pilot.
Yeah.
And I'll come around here, and I want to take a look at something, because something doesn't look right about this thing. Look around here and see. Now, who in the lab thinks that an SCA runs at 87 kilohertz?
Well, some guys with a sixth sense of humor, Chuck.
Okay, can we fix that?
Of course we can.
All right.
So in this case, when you want to change your SCA setting, we'll actually go into the preset that is active.
Mm-hmm.
In this case, this is the preset number 2.
Okay.
So as you can see, there's various parameters that can be adjusted.
Yep.
Output power, the frequency, the mode, injection level.
Well, I'm curious. Go back up for a second. Does this IDOC injection level mean that I can adjust that at some point in time?
At some point in time, you will be able to adjust it in 1 dB increments all the way to -10.
That's wonderful. Okay.
So if we scroll down, we'll see various other parameters, and we'll get to the SCA function.
Oh, there it is.
The SCA1 was enabled at 87 kilohertz.
Okay.
So Chuck, what do you feel comfortable with?
Well, 67 kilohertz is more or less the standard for most stations, so let's do that.
All right, and now we'll activate.
All right.
And if we close our preset screen,
hey, look, it moved.
We'll see that our marker at 87.
So I'm going to come over here now. And there it is. Now let me show one thing I know how to do, and that is to hit this gear here. In fact, I'm going to expand this screen and make it go to full screen.
That's right.
There's our spectrum analyzer in a large screen. Now I'm going to come over here to this gear. I don't want to look at an audio analyzer anymore. I want to look at the RF at the output of the transmitter. And so I hit done. That's going to take a second and normalize
it. Refresh and normalize. So
should take just a second, I hope. And looks like something started to happen. While that's happening, can you explain the meters over here?
Check your span. I bet you're.
Oh, okay, yeah.
So in this case, the span was adjusted for the audio spectrum analyzer.
Okay.
So we'll set it up for a 1 meg span.
Okay. Oh, yeah. Look at that.
There you go.
All right. Very good. So we're meeting the math.
A passing spectrum, what I like to see.
Good. All right. Explain the meters on the right-hand side.
Well, the meters are broken down into the device type. So in this case, you can see exciter A, forward power.
Mm-hmm.
In this case, we have 9 watts. The reflective power is 0.1 watts, but again, for exciter A. We have module 1, various meters within that module. We may have a few others here that have been selected. No, but I'll show you where those meters are grabbed from.
So in other words, you get to define what things are showing up on that screen.
Correct. Those meters are strictly there as a troubleshooting aid.
Okay.
You can look at specific meters or a various amount of meters in the way I'm going to show you right now. So if you want to look at all the modules and their parameters, go into the system review page and actually open up a screen that gives you a summary so you can compare how one module might be doing compared to another module.
I'll look at the amount of information that is available there. And the red marks means that it's updating?
It's just updated that value.
And I can see this from wherever I am.
This is all remote.
Even on my BlackBerry or iPhone.
That's right.
Wow.
So if we close that, we'll see various other. We can go into the controller. And every meter you see in this list is available as an item that can be pulled up in that right-hand bar.
Okay.
Okay, so you can see various values are changing.
Sure. I can see the RPM of every fan.
Yeah, we monitor every fan.
Mm-hmm. So there's a tachometer in every one.
It is a tachometer reading.
Yes.
So in order to pull up a specific meter, you'll see before we didn't have controller 5 volts, but if I load it, you can probably see that scroll bar change. If I scroll down, I'll see the controller 5 volt.
There it is.
If I choose to remove it, I close it.
There it goes. Okay. Now let's go close this part. Show me what these other meters on the work area here are for.
Well, being that this system is a FM plus HD enabled system, obviously we have the transmitter spectrum being shown. Mm-hmm. We have what we call the LUT height, which is the amplitude correction, and we have the phase correction. And we also have a lithogist pattern, which is just showing modulation.
All right, very good.
Details.
Now, if I wanted to close one of these, it would allow me to open up
a plethora of other tools.
Yep.
So in this case, you could open up an EQ impulse response. So if you had to have a tilt filter enabled, you'd see a variation in your EQ response. You can close this one and open up the signal constellation.
You don't have that connected at the moment.
Unfortunately, at this point, it is not connected, but that is available.
Okay. All right. So we're seeing a lot of information here. Let's go back and put that back where it was in the, I think it was the EQ frequency response.
That's fine.
I want to learn about the logging features in the transmitter.
Well, with the logging features, as simple as pressing the log button at the bottom of the screen.
Mm-hmm.
When you go into that screen, it'll show you a device type or device. These are basically filters that allow you to basically get down right to the device type that you're looking for. If you know you have a module 1 problem, you don't want to be confused with all the various other alarms or events that may have occurred in the time being. So you can actually open it, select controller, exciter, or power module. Device type is basically high-level filter for device. If you were to go in device, then it actually breaks down to the various devices that are in the system. So we have controller, exciter A, B, module 1 through 16.
Okay. How much data can you store in the log, Scott?
Well, the log file itself for each entry is actually very small from a capacity standpoint. It's probably only a few bytes, actually. So we can store, and I think I've seen the highest number was about 18,000 entries.
Holy mackerel.
So, and I think it would have gone more than that.
Yeah, and you can retrieve these logs.
You can retrieve them. Yes, you can.
Okay. Okay. So here's where you would change your exciter.
Actually, you'd go into the menu. The menu gives you the list of all the various kind of primary functions that are available.
Right.
So in this case, if you wanted to change your exciter, assuming you had a dual exciter in this system, where that would have been selected as yes, you would arm your changeover here, and in this case, if you had a failure on A, it would automatically change over to B.
As software upgrades to the AUI come out, Scott, or to other parts of the system, how are those distributed to the users?
Well, at present, it's actually quite simple. In the software configuration screen, there's what's called an upgrade software. We can do this various ways. You can actually browse for a specific file. If we've already provided what's called a TGZ file on your internal network, you browse for it, similar to what you would do in Windows, and you upload the file. This is the actual image of the TGZ file that's running on this system right now.
Okay.
So with respect to the upgrade process, as soon as you have that file in the bin, you select it and you begin flash.
Okay.
The transmitter will run through the flash sequence where it actually upgrades modules, exciter, AUI, server, and controller, and all at the push of a button, quite literally.
Now, we might be scaring some people. I mean, this is, after all, a computer.
Yep.
What happens if the AUI dies?
Well, as mentioned earlier, the transmitter controller has a full set of redundant controls. The transmitter will keep operating. It is not dependent solely on the AUI to keep running.